All right, let's just kind of go over it. I know that you're nowhere near done, but I just want to make sure that you guys have enough time to make up anything that you need, or you can do SSR because it is technically SSR day in math. So either one is fine with me. And I know a lot of people I actually been hearing in Code Talk class too that they like the book that they're currently, what are you guys reading?
Oh, I don't know. I don't even read that book. I was just kind of messing around.
Oh, so you weren't being serious.
I was actually pretty excited though to come in and at least catch up on it, but
Well, you're going to have a lot of time. It's going to take 5 minutes. But I was just wondering what the book was called.
oh, it's called The Things They Carry.
I heard that's a really, really good book. So, M&Ms, if you were able to count, which is really ironic, I didn't even plan this. If I were to count these, can I count them?
Yes.
Yes. So it's discrete. So discrete means that you can count it on your fingers. And usually when you see the number is kind of what's going to help you there. What about number 2, swimmer time in a freestyle meet? It's continuous. And that time is what's telling you. Time, anything dealing with time is going to be continuous because time doesn't stop. It keeps going. Yes, you can't measure that. All right, so now let's talk about this. We have, it's supposed to say 150, so just cross off this piece. It's supposed to say 150. I was typing it really fast this morning. 150 runners completed a local marathon. The table displays are the race times for the 150 runners. So that's the total. And whenever you're doing relative frequency, it's the number that you're looking at divided by the total. So when you do 5 divided by 150, what do you get?
0.033.
Good. And then what about the next one?
0.186.
Good. And I'm going to write this out. All we're doing is 5 divided by 150. 28 divided by 150. And then I want you guys to check your answers on these other ones. And I might have rounded, so if it's a little off, it's okay, as long as you're somewhere in the area. There. How'd you do on that one? Is it pretty straightforward? I think people just get confused on the word relative frequency. That really is just your average. But because we're talking about intervals, that's why we call it relative frequency. Usually it would be your average. But because we're talking about intervals like these, from any race times between 14 and 18, okay, we are talking about relative frequency. Now here's where people tend to get a little confused, is labeling your normal distribution. So we have the lifetime of a certain battery life is normally distributed. The mean is 42, and I'm going to draw out the symbol. It's called a mu symbol. It looks like an M, like a fancy M, but it's a mu. It's a Greek letter. So mu, or the mean, is equal to 42. And that always goes in the middle of your graph. And that's why I'm going to put 42 right in the middle. Your mean always goes in the middle. When you have normal distributions, your mean is always located in the middle. And we'll go over the homework that you guys had yesterday on Monday with everybody, because there's a couple errors on those ones. And the standard deviation is 1.2. We represent that with this thing called a sigma. And that's 1.2. It's like a little fancy Q or O. That's how you would draw a sigma. Think sigma, standard, they start with S, mu, mean. Okay, that's what those are. And the standard deviation is just when you go left and right, you either add or subtract, but think about your number line. If I go to the right, am I going to add or subtract? Add. So I'm going to add 1.2. What is 42 plus 1.2? 43.2. Yeah. And then what about if I go backwards? What am I going to do? Yeah, subtract 1.2. And that's going to get me 40.8. And I'll fill in the rest of them for you because I think you know how to add. 44.4, 45.6. Then this guy again, when we subtract 1.2, we get 39.6. We subtract again, we get 38.4. One of the things that we notice is a lot of people just struggle setting this up. You start at the mean, add when you go to the right of it, subtract when you go to the left of it. And the very last one, which is very, very easy, but you really need to know this because this is the third time you're seeing this just in the past 2 days. That means it's very important because there's something going to be like this that you're going to be assessed on. The normal curve pictured below represents the battery life of 3 different brands of laptops. Which brand would have the best choice if you want to be the most confident about the average life.
Brand B.
Not brand B.
C.
It's A, and here's why. I'll explain it. And the reason why we're going over this because it's the most incorrect question or incorrect answer that we receive on the assessment. The most accurate that you can be is when all of your data or majority of your data is really close to the mean. If you look at all these points, they're really close to the mean. Whereas here, your points are further from the mean. Over here it's further, over here it's further. So like the taller it is, the lower the standard deviation. Remember, tall and small. Which you want the lowest standard deviation because that represents that more data is by the mean. So this is just brand A. And that's why I'm happy that we're going over this because it's the most incorrect answer on the exam. The taller, the better. The taller your graph, the better it is, the more accurate it is. So you would trust this company to get your laptop because most of their data is really close to the mean, the average. Whereas this one's like really spread out. You might buy a laptop and be all the way over here. That's far from the mean. Whereas here, you're more likely to fall in this range. Okay? And that's it. Okay? So the rest of the time is either SSR, working on what you missed because you weren't here one of the days, or just sleeping. I don't care. Okay? Yep. Monday we just talked about what statistics is. We did this. From here to here. This is day 2. Then you're good. Okay, you're all caught up. So like numbers 1 through 3 were day 1. So if you were gone for day 1, but you understood what we just did, then you're good. But just do the homework. And then 4 through 5, it was day 2. So if you were gone on day 2, just do the homework. It's on edulastic.com. And when you log in with Google, it should just show up your assignments that you have.